So yesterday you looked at kind of what are the conditions, what are the things that happen with parallelograms that allow us to conclude that they're rectangles, rhombuses, or squares. So we're going to do a quick review of that before you get the reteaching assignment, just to kind of help solidify all that information. So let's talk about the few kind of properties that we know that we can then prove that these are these different types of shapes. So number one is that remember when the diagonals are perpendicular, right? I could say I have a rhombus, right? So anytime you know the diagonals are perpendicular, and say, hey, this has to be a rhombus. The next thing you can look at also with diagonals, right, is when the diagonal bisects each pair of opposite angles, right? So when a diagonal bisects the pairs of opposite angles, you can say, hey, this also is a rhombus, right? And so the last thing, when I look at diagonals, right, if the diagonals are congruent, you can say that I have a rectangle when that happens. Right? So those are kind of the three things you'll look at and say, okay, if I can prove any one of those things is true, then I have the shape that I have. So that'll be kind of what you're doing in problems 1 through 3. Right? Looking at the information that's given and then deciding if it's a rhombus, rectangle, or a square. The other type of thing you look at is say, they'll tell you, hey, I want this to be a rhombus, or I want this to be a rectangle. What value of x does that have to be? So this is going to be the rest of the assignment, right? 4 through 7. So if I were to look at this, right, a rhombus, so the first example, they give me a rhombus, and they say, hey, this would need to be a rhombus. What value of x makes that happen? So if you look, right, they tell me that I have this diagonal, and I have these two angles here. So I know from the kind of my form is that if it's a rhombus, the diagonal has to bisect those angles. So I need to cut that in half, right? So that means that my two angles have to be congruent, which means their measures have to be equal. So I can set them equal to each other and then solve for x. So if I do that, right, I do minus 4x minus 4x, I have 10 is equal to x plus 6. Subtract 6, so x is equal to 4. So when x is equal to 4, that's my shape. Right? So you look at that. The other thing you can look at, we'll do one more example. This time we're looking at a rectangle. And so the one thing I'm looking for with a rectangle is that my diagonals are congruent. So they tell me that SQ is 14, right? So SQ here, that's 14. So if I look and I know that diagonals are congruent, I know that PR, right, has to also be 14, right? That other diagonal, this blue diagonal, needs to also be 14. But I still have to find x, right? So it looks like I missed one label. So this is T in the middle there. That intersection point is T. So they tell me that PT, right, this first part is 3x minus 11. And the second part here is 1 plus x. So since I know that those two parts have to make 14, I kind of go back to that first unit and say, well, I can add segments together to get the whole thing, right? I can say, well, 3x plus 11, because that's my first part, plus my second part, right, has to equal the whole thing. So now I combine like terms, so I have 4x minus 10 equals 14. So add 10, 4x equals 24. If I divide by 4 and divide by 4, x is equal to 6. So that's kind of the problems we're looking at for this section. So that should get you through the assignment for today.